derivation of nernst equation. So first we will take, let us consider a reversible reaction, that is M is equilibrium with n plus n electrons. So here K is the equilibrium constant. So K is equal to concentration of products divided by concentration of a reactant. K is nothing but equilibrium constant, that is equal to concentration of products divided by concentration of reactant, M plus N by M into S. So this is a equilibrium constant K. Okay, if any reaction which occur in nature, any reaction which occur in nature, the maximum work done W max is equal to minus NFE, maximum work done, that is minus NFE. Okay, delta G is equal to minus NFE. So this is a change in Gibbs free energy, delta G naught is equal to minus NF E naught. So that is a standard condition. Change in Gibbs free energy, standard according to the Van 't Hoff isotherm equation. So that is delta G is equal to delta G naught plus RT into ln K. So this is a Van 't Hoff isotherm equation. Okay, we will substitute the delta G value and delta G naught value in this equation. So that is minus NFE is equal to minus NFE naught plus RT into ln. So K means nothing but the equilibrium constant, that is equal to concentration of products divided by concentration of reactant. So that is Mn plus by Ms. So generally, so the standard means when it is metal is in solid state, so generally we can take the value of solid is equal to 1. So here we will divide this equation with minus NF. So that is we are dividing with minus NF. So minus NF. So here the minus NF get cancelled. So the remainder is E is equal to E naught plus, so plus into minus, that is minus RT by NF into ln Mn plus. Okay, so this is R means gas constant. R is equal to gas constant, that is equal to 8.314 kilojoule per mole. T is equal to, we know very well, 298 Kelvin, means at 25 degrees temperature. So F is equal to 96,500 coulomb. Okay, so 96,500 coulomb. So N is equal to number of electrons loss or gain in a redox reaction. Okay, so here ln we will substitute. Ln is equal to 2.303 into log. Ln is equal to, we will substitute in place of ln 2.303 into log. So we will substitute all these data into the above equation. So we will get E is equal to E naught minus 0.0591 by n into log mn plus So this is a derivation of Nernst equation. So that is E is equal to E naught minus 0.0591 by n into log mn plus. Okay. So if the reaction is in equilibrium condition, when that is in equilibrium condition, generally what will happen? So delta G is equal to 0. So delta G is equal to 0 means the Van 't Hoff isotherm equation becomes delta G naught is equal to minus RT into ln K. K means nothing but K equilibrium. ln K equilibrium. So that is equal to delta G naught is equal to, we know very well, that is minus NF E naught is equal to minus RT into ln K equilibrium. ln K equilibrium. So minus minus get cancelled. So we will write in equilibrium condition, that is E naught is equal to RT by NF into ln K equilibrium. So we will substitute all these information into this equation. E naught is equal to 0.059 by n into log K equilibrium. So this is the equation for when the equilibrium means the reaction in equilibrium condition. So when it is in equilibrium condition, the delta G value is equal to 0. So the delta G value is substitute in Van 't Hoff isotherm equation. So 0 is equal to delta G naught plus RT into ln K. So we will substitute all these data into that above equation. So we will get E naught is equal to 0.059 by n into log K equilibrium. Okay. So these two formulas are very important for calculation of Nernst equation. Okay. Cell of the cell reaction was given. So that is zinc electrode and copper electrode are connected through a external circuit or connected with a salt bridge. When the concentration of zinc plus, remember students, so this is very important. What he mentioned here, the concentration of Zn plus 2 is 10 times to the concentration of copper plus 2. So here the first point is the concentration of Zn plus 2 is 10 times to the copper plus 2. So clear? Right. Next, the expression for delta G. So what he is asking, the expression for delta G in joule for mole. So here the Faraday is constant, gas constant, R is constant, and T temperature is constant. Okay, and also he was given the electrode potential difference between E naught cell, that is equal to 1.1. So here E naught cell is equal to 1.10 volt. So we will calculate. Okay, so we know Van 't Hoff isotherm equation, that is delta G is equal to delta G naught plus RT into ln K. So RT into ln K. So he is asking delta G. Okay, so delta G naught. So delta G is equal to, we know, so the delta G is equal to minus NFE, and delta G naught is equal to minus NF E naught. So here delta G is equal to minus NF into E naught. So delta G naught is equal to, we will calculate here. So N means the number of electron transferred in the redox reaction. So generally the equation is Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu, yes. So aqueous and this is aqueous. So this is the equation. So the zinc electrode is acts as a anode and the copper electrode is acts as a cathode. Okay. So here ln K or K is equal to, that is concentration of products divided by the concentration of reactor. Okay, here the concentration of Zn plus 2 is 10 times to the concentration of copper plus 2. So therefore here, so we can substitute in place of Zn plus 2 with copper plus 2, that is equal to 10 into copper plus 2 by copper plus 2. So that is equal to K is equal to, so we will get 10. So we will do. Okay. So delta G naught is equal to minus NF into E naught. So means the number of electron transfer in this reaction is 2 electron transfer minus 2 into Faraday is constant and the standard electrode potential, the potential difference he has mentioned, that is 1.1. So that is equal to minus 2.2 into F. So this is the delta G naught value. So we will find out delta G. So here the value is minus 2.2 F. So this is only for delta G naught. So in the given option, option A is 1.1 F. So it is wrong. So option A is not correct. Okay. So we will substitute this equation, that is delta G is equal to minus 2.2 into F plus, we will substitute ln into log convert, that is equal to 2.303 into RT. Since I'll write here, so that is ln is equal to 2.303 into log. Okay, clear student. So 2.303 into RT into ln K. So here, into log, that is equal to log ln is equal to 2.303 into log. Okay, so log into concentration of products, that is Zn plus 2 by Cu plus 2. Zn plus 2 by Cu plus 2. So delta G is equal to minus 2.2 into F plus 2.303 into RT. So we will substitute Zn plus 2 by Cu plus 2, that is K. So we will substitute, the value is 10. So into 10 into 10. So that is equal to delta G is equal to log 10. So the value is log 10 base 10. So log 10 base 10 value, that is equal to 1. So therefore minus 2.2 into F plus, so 2.2 plus something. So therefore we will remove option D option also. So minus 2.2 into F plus 2.303 into RT. So the value is equal to 1. So therefore here we will change minus 2.2 into plus into F plus 2.303 into RT. So therefore delta G is equal to 2.303 into RT minus 2.2 F minus 2.2 F. So therefore the given question here, this is 1.1, option C is also wrong. So therefore option B is correct. So the answer is 2.303 into RT minus 2.2 into F. So